In this video, I will talk about how to denote and estimate the one-sided limit from graphs. Here is a function f of x. The question is, what is the value of function f of x approaching as x approaches 2 from the values less than x equals 2? Pause this video and think about it. You may find this question is same as finding the limit of f of x as x approaches 2 from the left-hand side, and we can see that f of x is approaching 8. The way to denote this process is similar to denote the limit of f of x as x approaches 2. But we are going to specify the direction. In here, we put the negative as a superscript after the 2 to denote the negative direction that x approaching. Attention, this is not a negative 2. It means x approaching 2 from the negative direction or left-hand side, and the limit of f of x as x approaches 2 from the negative direction is 8. Since you get the general idea of how to denote the one-sided limit, I would ask you another question. What is the f of x approaching as x approaches 2 from the values greater than 2? Again, pause the video and see if you can figure it out. Well, you will find out this is the same as find the limit of f of x as x approaches 2 from the right-hand side. To denote this process, we just need to add a superscript positive right over here. And we can see as x approaches 2 from the positive direction, f of x is approaching 6. So the limit of f of x as x approaches 2 from the positive direction is 6. The condition of limit at x equals 2 exists is that both of these one-sided limit are the same thing. In this situation, they are different. The limit of f of x as x approaches 2 from the negative direction does not equal to the limit of f of x as x approaches 2 from the positive direction. Hence, the limit of f of x as x approaches 2 does not exist. Since we get this idea that in order for limit to have existed, the two one-sided limit must equal to each other. Let's solve another question. Does the limit exist at x equals 4? If does, what does it equal to? Pause the video and see if you can solve this question by your own. Okay, let's do it together. As x approaches 4 from the left-hand side, f of x approaches negative 2. The limit as x approaches 4 from the negative direction is negative 2. And as x approaches 4 from the right-hand side, f of x also approaches negative 2. So the limit as x approaches 4 from the positive direction is negative 2 also. Since the limit from the negative direction is equal to the limit from the positive direction, the limit of f of x as x approaches 4 existed, and it is equal to negative 2. Let's do another question to familiarize how to estimate one-sided limit from graphs. Pause this video and see if you can figure these questions out. Alright, let's figure them out together. As x approaches 2 from the left-hand side, the g of x seems approaching 2.8, and it may be 2.82 or 2.823456789. We don't know exactly from the graph. Anyway, I will say the limit of g of x as x approaches 2 from the negative direction is approximately 2.8. Next one. As x approaching 2 from the right-hand side, our g of x seems approaching 1. The limit of g of x as x approaching from the positive direction is 1. Since at x equals 2, the limit from the negative direction does not equal to the limit from the positive direction. The limit g of x at x equals 2 does not exist at all. Let's do one more example. Pause the video and try to figure them out on your own. Well, let's do this together. We will repeat same thing here. Let's say as x approaches negative 2 from the left-hand side, h of x is approaching 4. Hence, the limit of h of x as x approaches negative 2 from the negative direction is 4.